Today we're going to go over the command line. This is the first tool that we're going to be looking at. And so just a refresher, who has opened the command line before? Who feels comfortable using the command line on whatever system they have? Okay, not many. All right, okay, that's good. So I'm going to start very, very basic and show you some tricks that I hope you'll use. I'll hopefully make the command line less scary and a lot faster and more comfortable to use. All right, let's get started. So homework one is to actually get into Eustace, so everyone will be on the same system. So let me know if, ask on EdSTEM if you still have any issues getting into Eustace. This is how you do it, SSH, your NID, and Eustace. I've also given some notes here. If you look at the lecture notes, there are additional notes. I have all sorts of additional notes littered throughout the slides. And so there's some tips here on having a passwordless login, so you don't have to type your password every time. This is using SSH keys, so you can learn a little public-private key usage here. Okay, so getting really, really basic. This is what you should see when you log in. So I've logged in here to Eustace. So this is system specific, but there's a little welcome message here. And you get the command prompt. Who's seen the command prompt before? Hopefully everyone. I've seen a command prompt. So the command prompt, so this terminal system, it's just sending back and forth text. Well, numbers representing text symbols and sometimes representing commands as well. But we just basically have kind of like a chat window, just a text communication back and forth between the server. And what's actually running on here is software called the shell. And we're going to actually build a version of this. But there's a program running on Eustace that takes in text and runs commands for you, operates the machine for you. And what makes the shell so powerful is you have access to virtually the whole operating system library in a much faster way than just writing C programs. So compared to something like Firefox, which I have open here, Firefox has a specific graphical interface. Designers have designed it for very specific tasks. The shell is a lot more general purpose. You can run arbitrary programs. There's a lot of features for doing text processing. You can manage processes and files more directly. But what you effectively have is kind of like a chat window with this shell program. And by convention, the shell will spit out this command prompt. And this is actually customizable, but by default on Eustace, it's going to be your NID with an @ sign, followed by the host name, which is interestingly not actually Eustace, it's this, configured to be that, followed by colon, and then this little tilde here, by default is actually going to be your current directory that you're in. So if you've ever used a file browser, you've all used file browsers, right? Hope. They're not completely gone away. This is the current directory you're in, or folder on Windows. So this is a little esoteric. It's a little tilde. It might be hard to see, but this is actually a tilde. But if I go to some other directory on my system, like user bin, you can see that this spot, color-coded in blue by default, this is going to be the current directory that you're in. So the shell and the operating system keep track of some state that remembers what directory you're currently in. And so why is this useful? Why bother doing that? Well, that's so when you explore your file system, you don't have to remember where you want to do your operations. So for instance, if I want to list what files are in a specific directory, I use the ls command, which is like shorthand for list, L-I-S-T, list. And the system will, or the shell will look at whatever directory I'm currently in and use that as the input to my command. So ls, you can give it a command, you can give it a folder to look at. So I'll ask it to look at the home folder. And ls will give me the contents of that home directory. But if I don't give any contents, it'll default to just whatever your current directory is. This is called the current working directory. And every running program on a Linux-like system or a Unix-like system, the operating system maintains a current working directory for each process. right, so questions on this? So the first command that we're going to look at is ls for listing. So in Windows, you might have seen dir for directory listing. But in the Unix world, the command is ls. Questions on this? Questions on the command prompt, especially if you've never seen it. And so notice every time I run a command, it gives me the output of the command, and it reprints this command prompt for me. And also in my terminal, I don't know if it does for you, there's this blinking white box, and that's the cursor. That's the place where if you start typing input, the shell will echo or repeat what you've typed so you can see what you're typing. And that allows you to get some feedback as to what command you're going to be giving to this command shell. Just a little too specific and too low level for those who have experienced this may just seem really obvious. But if you've never seen this before, this could be very surprising. But just like Firefox is a running program, we have a shell as a running program on here. And when you start running it, it just sits and waits for you to type input through, in this case, through your keyboard, through the terminal, through this terminal program, into the input of this program. So this is like, what did you use for input when you learned C? Scanf? Scanf, right? So you can think of bash as just a program in a big loop, and the first thing it does is prints out this loop, printf, and then says scanf on whatever your input is. And it's sitting here waiting for the user to type a command. All right, questions on this? So to operate this, you just type whatever your command is and hit the enter key when you're done typing the command. And the bash shell will go out and do whatever you've asked it to do, whatever command you've asked it to run. So in this case, I'm asking it to list the contents of my current directory. Questions? Okay. All right, so a little tip. So some people type clear, but a little tip, you can do Control L. So you can't see that I'm typing it because it's not non-printable stuff being sent. But if I type Control L, it's a faster way to clear the screen. Also, when I write example commands, I use this a lot. I realize I didn't explain this last semester. This hash mark is like in C. In C you have double slash for comments. In the shell, at least bash shell, hash mark is comments. So this does not get run. So it's the same as if I hadn't typed it at all. So if I forget that hash mark, then these aren't going to be comments. These are going to be part of the command that I'm giving to the shell. Questions on that? So just remember, if you see, especially, I'm going to give you lots of detailed bash commands to run. You'll see comments here, and I'll just put explanations there as to what's going on. A little trick as well is if you're trying to work out a command and you haven't finished working it out, you can comment out the line, hit enter, and then it's saved through in the history of the shell. But I'll get into that a little later. All right, questions on this? Questions on comments? All right, so to help visualize while I do this, while I navigate this file system, let me go over a few key points about the file system hierarchy. We'll talk about files more when we get into actually implementing file-based stuff. So let me go into some conventions here. Let's take the directory that I was in here. Let me go to this directory. So I'm in /user/bin. So for every Unix-like system, the entire file hierarchy always starts with a folder called root, which is denoted with a /. Who's seen this before? Who's seen the root file system? Yeah, not many. So if you're on Windows, Windows has a different convention. Each drive, at least as far as I remember, each drive has a separate letter. Do they still have drive letters in Windows? Yeah, so there's no single root of the file system. In the Unix world, it's different. Instead, there's a single root file system, and if you have external drives, they're attached as subdirectories in this system. But take an OS class, you'll learn more about that. And by convention, which you're probably familiar with in the world of URLs, internet URLs, the / is the file separator in the Linux world, in the Unix world. So to look at the file hierarchy of this folder here, this is saying this folder bin, or this directory bin, is under root, and underneath root, because root is / underneath root, there's a subfolder. Oh, that's not writing. There's a subfolder here. There's a subfolder called USR, user. And that slash here, this slash itself is actually not another directory. It's just notation to tell you that you're separating names of directories. So this user folder here, if we were to go inside of the user folder, so now the prompt tells us we're in the user folder, you can see that bin is one of the files inside of the USR folder. So this, what's called a path, is describing the folder bin as a member of the folder or directory user, which is a member of the directory root. Questions on this? Questions on file system hierarchy? And so to specify a file that is nested within several directories, we combine all of the directories, all of the parent directories in order, and separate them with /. Oops. Oh, I went very far back. Okay, and also by convention, which we can see with this magical command ls-a, which you can think of as all files, every directory in the Unix world has two special directories called dot and dot dot. And so again, this is some pretty esoteric syntax or pretty esoteric notation that's used as conventions. And so these are special directories that appear in every directory in a Unix system. And so the dot, so who's ever seen the dot directory before? I think you must have. Did you ever run, say, dot like this, /a.out? And you probably wondered, why do I have to do /? You know, you're probably just told to do it. And you know, that dot, this a.out was in your current directory, so why do you have to give a path to it? So that dot folder is actually a pointer to the current folder. So if I were to change the directory to dot, I'd just stay in the same directory. If I were to run this path here, it's referring to the same directory, so you're not going anywhere. You're just saying stay in user, 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 and then run the program a.out. So why do this? Why bother doing this? One reason is that you want to be able to distinguish between a command like ls versus a program you may have written in your current folder called ls. So I can run the ls program, which is a program, but it's not in my current directory. There's no program called ls here, but I can run it here. I can't run .ls because my current folder doesn't have something called ls. And so one feature of the shell is to automatically find programs to run for you. And so there's a command to tell you which folder or which directory the command is actually in. And here, the ls program is actually in this folder. It's in /user/bin/ls. So to look at our file system hierarchy here, inside of bin, I'll make this here. Inside of bin, there's a file called ls. That's my ls program that I'm running. And the bash shell has functionality to automatically search out programs to run in predefined locations. Okay, so that's the dot folder. So might seem a little unnecessary, a little superfluous, but as you get used to the Unix world, it makes more sense why there is a dot folder. The dot dot folder, who's seen the dot dot folder? And you've probably seen this in Windows as well, so not many, okay. So the dot dot folder refers to whatever the parent is. And so why would this be useful? So why do you think? Why bother having a reference to the parent? Yeah.
So that you can go back.
Yeah, so you can go back easily. So it's very easy to go kind of forwards in the tree here. So if I'm inside of the user folder and I want to enter the bin directory or folder, then I can tell my system, give me the bin folder. Go into the bin folder. There's no listing here of what the parent directory is. But by having this dot dot folder, I can reference the parent from anywhere in my system without knowing its name. So that's the convenience of having the parent folder. Questions on this? Questions on just the file system hierarchy? Yeah.
Does the root have a dot dot folder?
That's a good question. So we can actually check for ourselves. We can check for ourselves whether it has a root folder, and it does. It has a parent folder. It has a current folder, and it has a parent folder. So what is the parent of the root? The root has no parent, right? It's just the root itself. So it actually points to itself. So that's a really good question. So the dot folder for the root points to itself, because that's what the dot folder does. But for the root and the root only, the parent points to the root. So they don't have, it's like the beginning of time, what's before the beginning of time. So they resolve that by having the parent point to itself. Questions on this? Questions on the file hierarchy? So you'll hopefully get more accustomed to this as you are using Eustace. And one reason I wanted to avoid MobiTerm or visual browsers is because it's good to have this in your head. So this file hierarchy in your head. And the system here the shell will tell us our current folder so we can orient ourselves in this tree. And you can think of that current working directory as a little state that holds where we are in our file tree. So if I use a command like change directory to move into the user folder, then this dot, the shell will keep track of which current working directory we're in. So every time I move around this file tree, the shell is keeping track of which directory we're in. And that's useful because if we run commands like ls, or we want to print something, like we want to print, there's nothing great in here to print. But if we want to run a command, for instance, that's in this directory, then the current folder you're in matters because we can reference files relative to the current folder we're in. So when a path doesn't have a / at the beginning, it's called a relative path. And the way you figure out which path you're referring to, the way the shell does it, is it takes whatever the current working directory is, which we can find with this command, and it adds it to whatever directory you've asked for. So when I say /curl, the shell is taking whatever directory I'm currently in and effectively appending whatever directory I've asked for. So that's relative paths. We'll talk about it a little more when we get into files, but I just want to give you enough so that we can navigate this file system. Questions so far? I know this might be a lot to take in if you've never seen this before, but yeah.
So curl means put like a name of something in front of it in order for it to append it to that file directory, or are you saying that code itself?
Shell. The shell will do it. This program, this command prompt program, will do that for you.
Okay.
So whenever you type a path that doesn't have a /, not an absolute path, it'll take whatever this is and put it before what you're running. So to illustrate this, let me illustrate this with an example you've probably seen. So if I have kind of the canonical Hello World program, you know what? I realize I should make this easier to see for you. Sorry about that. This is my classic Hello World program. So what do you do when you compile this? So ls will show us what's in our current directory. So hello.c is in here. So what do you do to compile it? You run gcc, or let's just do it the super lazy way. Let's just do gcc hello. If I type ls again, I'm going to see that now my folder contents have updated. And how did I reference hello.c? I just said hello.c. If I were in a different directory, like let's say I was in the fs directory, So you can see here that this tells me what my current directory is. You can also say pwd for print working directory to tell what your current directory is, but you can use the shell to tell you. If I try to compile hello.c, why doesn't it work? Because it's not in the same directory. So this is a relative path to that file. Now, you don't have to change directory to compile this. You can just reference through, well, so I could do this the long way and take the full name of my folder, the absolute path to my folder, and compile it. Sorry. Let me make this easier to see. So I can take the full path to that hello.c program and compile it that way, and it'll compile just fine. I mean, it puts it in my current directory, but it'll compile just fine. But this is where the parent directory shortcut comes in handy, this alias. So I can instead, knowing that my parent directory has hello.c, I can compile it this way. So no error, right? With hello.c, I get an error. Using the parent directory, it actually will find that file for you. So similar with ls, I can search or I can have it list what files are in my parent directory by just passing whatever path I'd like to look at the files of. Questions on this? Yeah.
So when you're compiling again, does it just overwrite the a.out, or does it make
Yeah, this is GCC's behavior. It's gonna override it. Yeah.
Okay.
Yeah. And so similarly, so this is why you have to write a.out. So if I just run a.out, command not found, right? So this is the shell's behavior. But if I give a path to it, so if I, for instance, I give a path to it in my local folder, it'll work. If I can also give a path to my parent folder or any other directory on my system, and it'll also run it. So these are actually two different programs. So to illustrate that very quickly, so I'm going to compile the hello in my fs directory and run it, and I get hello world again. If I run the a.out that was in my parent directory, it's a different file. It's a different program.
Okay.
So that's why you have to do /, because the shell will not run programs that are outside of a predefined directory. So just if you're curious, there's an environment variable. Read the text that I'm giving you. There's an environment variable, which is just just variable states that the shell maintains, that the system maintains, and it lists if you've ever had to manipulate, who's had to work with the shell, the bath in their system. So not many. So it just keeps a list of all the directories that have programs you can run. More like almost like a security feature. So you're not just running arbitrary programs. All right, questions on file hierarchy? Yeah.
This seems to run a lot similar, and I know this sounds crazy, but this runs similar to DOS. Am I making it right?
Oh, absolutely. Yeah. Well,
exactly the same, just different.
so it's not exactly the same. Historical DOS, I don't think had subdirectories. It didn't have a hierarchical file system. It had drives, and you could have one directory.
Yeah.
But it didn't have nested directories. The historical DOS. Windows now does have a hierarchical file system, but we'll read a paper, the original Unix paper that talks about hierarchical file systems. But these days, yes, all of these systems use a very similar file system hierarchy.
Okay.
But I think original DOS, you couldn't have, correct me if I'm wrong, if anyone finds, you could not have this subdirectory here.
You're correct.
Yeah.
I don't think even Windows had subdirectories until like 3.1 or something.
That sounds about right, yeah. So this hierarchical file system, so this goes back to Unix and even predates Unix. So this was an innovation in systems. So if this is confusing or you've never seen this before, you have to learn this. Somebody invented this. This is not like a law of nature that everyone should know. Somebody invented this. And we'll talk actually how this gets implemented a little bit when we talk about go to systems programming. Okay, questions on this? All right. Okay, so I went over an example. I went over paths. I think I went over all this. Okay, so yeah, to run commands, I think I said this already. You run the command and hit enter. If you want to figure out where you are, get the full path, the full absolute path. Use pwd for print working directory. But your shell is likely already configured, at least on Eustace, to show you your current working directory. If you want to see what's in here, ls for list. Okay, so I showed arguments already. So by convention, shell programs, programs that are designed to be written on the shell. You have the name of the program to run, just like a.out, and you pass with space-delimited text. You pass in all the things that you'd like to, all the arguments that you'd like to give to the program, and these are program-specific. So for ls, you can give it a list of paths to print out. So here I've given it dot, and /user, and it'll print out all three of those for me. So this is program dependent. You're going to write your own programs that take arguments, but this is just a convention in the Unix world. All these programs have some argument definition. If you want to learn what these are, if you want to look at the documentation, there's another program called man for manual. You give man and then the name of a command, or actually even a C library function or a system call, and it'll open up documentation for you. So it'll actually tell you the structure of the arguments and what you can do with this program. And so I have sort of canned commands that I have in muscle memory, which I suggest you also do if you want to become proficient at command line. But I'll use these man pages all the time. They're called man pages to look up, to remember how to do something with these tools. And so these can be quite extensive, as you can see. This is just a tool for listing files in a directory, and you can see it has dozens of options and features. So this convention here is, so for instance, if I wanted to list more information, I do the L option, the L flag, and by convention these are prefixed with a slash. So this is just the Unix kind of world's convention around their command line tools. Yeah.
Are you able to just type in manual and it prints out everything? Or
No, it'll tell you what to print out. So you can see the manual page for the manual. It'll tell you to run that. Yeah. Very, very self-referential. All right. So to move directories, it's the cd command. Who's used the cd command before in any system? All right. Okay. So everybody knows about this, and I've been using this already. So cd, change directory, cd, ls, list. So I'm changing directory to the parent here, and I just kind of by rote, whenever I'm in these systems, I'm always typing ls, pwd constantly just to orient myself. So that I know where in this file hierarchy I am. And you don't need a graphical system to do this. You have these tools to help you situate yourself in the file hierarchy and figure out where you are and what's there. So for instance, if you're trying to run a.out and you're like, whoa, it's not working. I thought I just compiled it last time I logged in. Use ls to see if it's there. You can see all the secret stuff I have here in my file system. And pwd to see where you are, or just look at this note here. And then that'll help remind you where to get back to. So one issue is that if I quit, if I log out, so you can type exit or control D is a shorthand way to do that. If I log out, when I log back in, I'm going to be back in the my home folder. I'm not going to be in whatever folder I was in when I quit. So that could be confusing if you get disconnected and reconnect. Make sure you use pwd and ls to situate yourself and get back to where you're doing work for the class. Oh, it's taking forever to load. Okay, there we go. So you can see that here I'm not in the COP folder anymore. Oh yeah, so quick point, the tilde. Tilde is a shorthand for your whatever your home folder is. So this is another Unix convention that each user has a directory assigned to them if they have shell access. And so tilde is just a quick way to get back to your home folder. So you could, if I'm inside of my project folder, I can go back home with just change directory tilde. And even faster, I can just say cd without anything. So this is kind of the Unix philosophy, good defaults to make you faster. Cd without anything also always takes you home. And one little trick, you don't have to remember this, but cd/, it kind of looks like tilde, takes you back to whatever the last folder you were in, if you want to alternate between folders. Just that's a little time-saving tip. You may not need to use that, but okay. So parent directory, we already went over much of this. So going to the parent, going to a subdirectory. Okay. So this is probably, if you take anything away from this and you've never used a Unix system before, probably the best and most useful feature for making the command line fast and navigating the file system is called tab completion. Who's used tab completion? Okay, good number of people. Okay, almost half. All right, so tab completion is autocomplete. Before autocomplete existed for phone, before phones existed, cell phones, tab completion is like the original or one of the original autocompletes. So let me show you what I mean. So I see so many students just typing out this long folder name all the time. And it's painful to watch because you don't have to put yourself through all that struggle and all that trouble. So if you've ever been put off by the command line because you just have to type so much, I can just start typing a few characters and hit the tab key. You can't see on the screen what I'm doing, but I'm hitting the tab key and it auto-completes for me. Pretty cool, right? This is very, very useful for making it fast. So when I'm on the command line, I'm constantly hitting tab all the time. So what happens if you type a prefix that is shared by many files? Well, it doesn't complete. I'm hitting tab, it's not completing. If you keep hitting tab, it will show you all of the files that match that prefix. So this is actually a really fast way to navigate your file system. You don't have to type ls. If you don't remember exactly what the file was, you can say, okay, I remember it was COP something, but I have a couple classes this semester. And it'll show you all the prefixes. And you just continue typing until you have a single possible completion. And then when I hit tab, it will autocomplete for me. If I keep hitting tab, it'll just keep auto-completing. There's only a single file inside of that folder, so it'll just keep keep going, keep working for me. Questions on that? Tab completion, use it constantly. Just always type ls, always use tab completion. Yeah? Oh, that's a good question. Yeah, so if it isn't there, it just won't work. If you haven't, so I've configured this to turn off the terminal bell. I think by default it'll ding, which I find very, very annoying. But yeah, you can configure it to ding. Some terminals you can have it blink, but I just get the lack of any output as a confirmation to me. So I'm hitting tab repeatedly here, and it's not working. So it'll say here's a prefix. I hit the wrong number. Tab doesn't work anymore. So you'll hear it on the audio, but I'm hitting tab aggressively here. So tab completion, use it all the time. Use this as muscle memory whenever you're typing stuff. This is the kind of impatience virtue that Larry Wall, what I talked about last time, that the frustration you have with your computer being slow or your slow use of it. Just constantly hit tab to help yourself navigate the system. You can also even do tab completion for commands. So this is warning you if there's too many. But this is everything that starts with L. This is everything that starts with LD, all the commands. It works in all sorts of places in the system. It even works with, I think, does it work with Git commands? Yeah, it even works with Git commands and other, like certain commands have registered these autocomplete specifications, and so you can use them with all sorts of commands as well. So if you take anything away, do tab completion, and your command line experience will be much, much better, and then you'll be a computer ninja and wizard in no time. Okay, so yeah, as I said, impatience. Don't spend time typing. Avoid typing as much as possible. This is the command line. So typing is your only interface, but use these tricks to make it fast. And it's also laziness because you don't have to remember the names of stuff. All right, so I did these. I already went over this. So make it a habit. Okay, another feature that makes things really fast is you don't have to retype your command if you make a mistake. So let's say I'm trying to compile hello.c, and I'm like, oh, I made a mistake. So, let's say I'm typing it, and I'm like, all right, I got to delete, right? You don't have to delete. You can use arrow keys, or actually the Emacs commands that if you took the tutorial, you can use home and end, and you can use the arrow keys to move yourself back and forth. You can even use commands that will jump between words. So I do this all the time. If you ever see me, on the command line, it looks like I'm very fast. I'm just taking advantage of all these techniques. But just use your arrow keys for now, before while learning these commands. And so I can just go back and edit my command. All right, so here I made another mistake and I already hit enter. What do I do? So the second to tab completion, the other best thing about the command line, the shell, is that it saves all of your prior commands. So you don't have to retype everything. So if I'm doing development and I need to edit stuff here, maybe I want to return something here, and I compile hello.c. If I want to run Emacs again, I just hit the up arrow, or the Emacs command for up. and go back to my previous commands. And so I can very quickly do some more editing here, and in no time at all, be recompiling and rerunning. So edit, recompile, rerun. Faster than many IDEs, perhaps, even. You could even be faster than that. So this is like the workflow. If you remember any workflow at all in the command line, this is like a really fast, super simple workflow with very little tools. Command line editor, and I'm also, I can use tab completion to help me with this, so that's why it looks so fast. Tab completion, and up arrow to repeat previous commands. All right, so this is called the history. I can run history to print all of them. So this is a power tip. You don't necessarily have to do this. You can actually search through all your past commands as well with Control R. But don't worry about that one. Look that one up. You can just Google that one. Okay, questions on this, rerunning commands. So come into my office and you're debugging. I want to see you hitting tab completion and the up arrow so that you're not spending hours of your life typing out stuff on the keyboard. And you'll be happier, you'll be less frustrated, and you'll be faster at doing this. You won't have that roadblock. So this is like the most basic workflow that you can all use. Editor. And when we get to processes, I'll show you another trick for not having to quit your editor. You can actually pause the editor and restore, go back into it. But we can show that later. All right, questions so far on the command line? All right, so tab completion, bash history, use those, and your command line experience will be much, much better. All right, so these are I just give a bunch of commands here. So you can use this command line notes as like a reference for now to help you, so you don't have to remember all this. I know there's a lot here to remember. Also, just Google stuff because this stuff is all over, all over tutorials on the web. So there's another trick I already mentioned before that you can, if I don't want to run this yet, I can put a hash mark before it so I don't have to run it yet, and then I can go back to it using the history. All right. Let me go over a couple of the common core utilities or basic commands in the system. So cat, if you want to print a file on the command line without having to edit it. Cat for concatenate, I think it's called, concatenate. And you can see here that without having to go into my editor or do anything else, I can just print out the text of a file using the cat command. Don't worry about these other ones. These are other versions of commands. Less is useful because you can scroll up and down in the file, but Q to quit. It's easy to get stuck in these commands because they don't tell you how to exit. But Q to quit. But yeah, you can just use cat and scroll up and down if you don't have a headless system. Okay, so that's a cat command. I have some shortcuts in here for if you want to use that less command. It allows you can use your editor, you can explore your file, but this is a way to do it without opening the editor. Okay, so Emacs. Okay, so here's the trick about keeping your editor open. So let's say I don't, if I have a long file, every time you open your editor, it starts at the top. So instead of quitting, you can hit Control-Z. You can't see I'm doing it, but you can hit Control-Z to pause your program, and the shell will actually manage multiple running programs at the same time. And now I can go back and recompile and rerun my program. And without having to reopen the program, hit FG for foreground to resume your editor. And now I'm back where I left off inside my editor. So this one's a lot more to remember. You can use this as you can go back and try out this workflow. But this is like super fast workflow with almost no tooling except that you have on the command line. So Control-Z to pause it, and you can do whatever else you want on the command line, compile, whatever, and FG to go back. So be careful that you don't open many versions of Emacs because you're editing the same file, and you could run into problems. If you want to check what things you have open, the jobs command will tell you what you have open. So it's another trick, kind of a fast workflow. There's instructions. You'll use this in homework too. You just follow these directions. This is how you can actually go to web pages from the command line as well. Yeah. Control Z, paste your clipboard from your system. So it's system dependent. So in Windows on PowerShell, apparently it's Control V to paste. Unfortunately, so on my system it's Control Shift V. Depends on your system because that's your windowing system that is managing that rather than the shell. So to the shell, it just sees very, very fast typing when you paste. But check Google it for your own shell. It sounds like PowerShell is Control V to do it. Yeah.
Talking about that, if you could like deactivate the control V so that the actual using Linux should be also paste.
Oh, Shift V. Control Shift V or just Shift V? Ooh. How do you do capital V? Have to hit caps lock, I guess. That's a.
You can change all the settings, so if you go to like the tab, right click.
Okay. Yeah, I encourage you guys put this on EdStem for other Windows users, and took a note of this as well. But yeah, this is dependent on your terminal system. But yes, you can paste into it with most windowing terminals. So I think this is homework 2, right? Yeah. So homework 2 has you use this command line tool called wget. This will download stuff from the internet for you. It'll download stuff from a URL, so you can actually scrape web pages with this. You can download entire web pages. Careful doing that because some web pages will start blocking you if you make requests too fast. But you can do your entire computing life on the command line. There are web browsers, there are games. People have ported Doom to the command line, I think, and Quake. ASCII, yeah. There's ASCII versions of Doom and Quake. So you can stay on the command line. There's calendars, there's email. There's everything. There's browsers, web browsers. Let's see if they have a web browser on here. So this is here we go. Here's a web browser. So it's not going to look pretty, but it's not going to have all the nice graphics and colors. But here's the CS department web page in the command line. Let's see how these look. I never tried my own pages. Yeah, it looks pretty good. Doesn't look too bad. So yeah, you can do everything on the command line basically. So this is just showing you how to download files. Homework 2 will go over this. Okay, so let me go over editing the file tree. So these are all the commands that. So for homework, you're going to use these commands to actually manipulate a file tree that I've given you. So touch creates a file. So if I want to create an empty file, I use the touch command. And you can see here now, new file exists. It also updates the timestamp of a file. So you can see here that new file was created in 10:06, or let's do hello. So I'll touch hello, and it doesn't overwrite it. It just updates the file stamp to be 10:06 instead of 10:02. So touch will create a file. RM for remove, MV for move or rename. Moving and renaming are kind of the same thing, right? You just change the name of it. CP for copy, MKDIR for making a directory, RMDIR for removing a directory. So one little caveat on remove directory is that it will refuse to remove a non-empty directory, so that it won't recursively go through and blow away your directory. So if I make a new directory here, MKDIR, you can see it here. Here's my new directory. I can look inside it and see that it has nothing inside, and I could remove that directory. And now it's gone. But I can't do that with FS because it's not empty. So how could we remove the FS directory? So there are commands that will do recursive deletes. I would say a safer way is to, so let me copy this first so I don't completely blow it away. I would say if I want to delete this, a safer way to do it might be to try to delete everything inside. So star is a shortcut for everything in a directory. And so now I've removed everything in FS2, and now I can remove the directory. Yeah. No, you'd need to do RMDIR, yeah. You're saying subdirectories, right? So like FS2, and then, so yeah, if I do rm fs2 star. Yeah, it won't delete a directory. RM will not delete directories unless you explicitly tell it to. Okay, so these are the commands. I went to directories. All right, so let me just illustrate some of these commands, something like you'll have to do for homework. So here's my new file. RM removes it. So you can see I'm typing ls after every command to show you the effect of it. Let's make this new file again. Move so this is why move is basically like a rename. If I move new file to the same directory but a different name, then you can see I no longer have new file here. I have a file called different name. So similarly here, so move is rename. But move can also do move. It can move files between directories. So here, what's gonna happen if I run this command? If I say move this new file ... Where's this file gonna go? Parent directory, right? So right now, my parent directory does not have a file called that. But if I move, then now my parent directory does have a file called back to new directory. All right, and copy is similar, except so copy will take either the name of a file or a path as its second argument. And now I have a copy of back to new file in both locations. Yeah? Yeah, it'll be all files except directories. And the last argument will be the destination. Yeah, you can use star. Yeah, you can use star. Star will be all files. Yeah, I'm not going too much in detail about the wildcards and recursive deletes because you can blow away your file system very easily. So, if you do RM or if somebody's trying to troll some naive computer user, they might trick them into deleting all their files on their file system or something. So these are the basics. For the homework. Let me start the homework here. So I have you, So just run this wget command. This will download from my website. So this is what you'll see. You'll see something like this, sending the HTTP request. And then you should have a new file called hw2 in your home directory. Let me make sure I don't have that already. And I do have it already. So let me move these out of the way. All right, let me get this again. So you download it. You'll have a new file. If you type ls, you should see a new file in here somewhere, homework2.tar. So this is the Unix version of zip, predates zip. This will unpackage it, and now you'll have a directory called hw3 in your home directory. Oh yeah, sorry. So I made a typo here because I copied this from my last class. Go into homework 3. I'll change this to be homework 3, which will make things confusing. Apologies for that. This tree command will print out the full listing of the directory. Or maybe I should change this to homework 2. Would that be less confusing if I change the tar file to be homework 2? All right, let me do that. I'll change this back to homework 2. Sorry for those who started the homework already, but you won't get anything wrong if you have this. I'll change this back to be homework 2. So I'll use the move command conveniently for class. All right, so now I have homework 2 like it's supposed to be. So you can just cut and paste these commands. All right, so the goal is to turn this tree into this tree. So for instance, I have a file called let's see. So fs.ext4 aclc. So I've got a directory here called fs with ext2 under it and something called acl.c under it. So instead, this directory is called ext4 in what the task I have for you to do. So let's take a look inside of this fs folder. We see ext2. So what command can I run in order to change ext2 into ext4? Move, yeah. And so how do I reference this ext2 folder? There are multiple answers, right? So, but what's one way to do it? Yeah, so I can use a relative path to it, so I don't actually have to change directories necessarily. And then I can change it to be fs ext4, so it's still underneath the fs directory. So if I just did ext4, well, that wouldn't be quite right, because now fs is empty and my ext folder is here. So what I really wanted to do, I'm just going to reverse this back to the original. So what I really wanted to do was move fx ext4 into fs ext2 into fx ext4. So now if I run the tree command to see how my files have changed, you can see that now my current system matches a little bit more what the output is supposed to be. Questions on that? Questions on that homework task? Yeah.
When you move the directory, or just the file contents?
Yes. Yeah. Yeah. It's like grafting a tree, branch to another branch or another tree. It moves the entire subfolder. And when we get into file systems, we'll see why that is and how directories work. Directories are really just special kinds of files that have data in them. They're just files that list their children. All right, questions on this homework? Yeah, sorry.
Not necessarily the homework, but earlier you said to delete a file or directory. What if you accidentally delete something that you wanted? Can you recover it? Or?
So technically, yes, not within the system. So if you delete it, bash will not help you. You're done. Your file is not visible to you anymore in bash. But technically, and actually we'll see with directories, deleting a file doesn't actually delete the data from your hard drive. It just removes the reference to it. So directories are just lists of names and file numbers. They're called inodes. You'll see this in the Unix paper, so yeah, we won't see this for a couple weeks, but it'll explain in the Unix paper how files work. So it's really just delete. It's like deleting someone's name from a phone book doesn't end their phone service. So it's the same thing, and that data is actually still on your hard drive, which is why there's many, I think, legal cases and court cases where people have thought they deleted files, but the content is still on the disk. So it's not visible to you from the system explicitly, but the data is actually still on your hard drive. All right, so with that, everybody have a good weekend and everything. Don't forget about homework 1 and homework 2, and I'll see you next week.